In section 6.2, we'll talk about transforming and combining random variables, but for today we'll just concentrate on transforming random variables. So if you recall from chapter 2, we've actually already done this with just one variable data. We talked about what if we add or subtract a constant from every single value of our data set, and we decided what happens is that measures whatever that constant is, the A, to the measures of center and location, so meaning mean, median, quartiles, minimum, maximum. It increases all of those by A, but it doesn't change the shape or the standard deviation or any other measure of spread. However, if we multiply or divide by a constant, it changes all the measures of center and location and all of the measures of spread, and those to get multiplied by B. Notice that on measures of spread, it multiplies them by the absolute value of B. Then that's just because standard deviation is always positive, so if for some reason you were multiplying by negative B, your standard deviation would be actually just multiplied by the absolute value of that. Again, the shape of the distribution does not change. So these same things happen when we look at random variables. So here's an example from El Dorado Community College. And it says a student is full-time if he or she is taking between 12 and 18 units. And what we have here is a distribution of the number of units taken by full-time students and the probability that a student is taking that number of units. So it asks you to calculate the mean and standard deviation of this distribution using your calculator. So if you'd like, you could take a moment and pause the video and just enter that into your calculator and do that now just to make sure that you're getting the right answer. I've already done this, however, and it turns out that mu of x is 14.65 and sigma of x is 2.056. Okay, so that's just the average number of hours taken per student, and then the standard deviation, which gives you the average difference from that mean number of hours. So then this next example has the tuition for full-time students is $50 per unit. So we have a new random variable t that is the tuition charge for a randomly selected student, and t is just 50 times x. So if you'll notice that all of these values in our new table are just, this one is 50 times 12, and this one is 50 times 13, and so on. I've just taken all of the values of x in the previous example and multiplied them by 50, and now I have this new distribution for the probability that a particular student pays a certain tuition. So it asks you again to use your calculator to find the mean and standard deviation of this new random variable. Again, you could pause your video and do this on your calculator now, but of course I've already done it. And I got that the mu of t is 732.5, and the sigma of t is 102.8. And I know you're probably wondering, well, what's the significance of that? Well, if you look at the mu we had before, it was 14.65. And if I multiply that by 50, you may not be surprised to find that that's 732.5. And if I take the standard deviation from before and multiply that by 50, I get 102.8. So what I want you to see here is that when I'm trying to find the mu of t, well, t was just mu of, it was 50 times the x's. So this just becomes 50 times mu of x. I can just multiply the mean of the random variable x by 50 to get the mean for t. And the same thing for sigma. Sigma of t, well, t was 50 times x. Oops, that should be a sigma. So this would just be 50 times sigma of x. So the mean and the standard deviation get multiplied by 50 also. So here's a summary of that. If we multiply by a constant, it multiplies all the measures of center and location and spread by that same value, absolute value if it's negative for spread, but we do not change the shape. So what happens if we add a constant? So again, back to the El Dorado Community College, the students are also assessed student fees of $100 per semester. So their overall cost will be the cost for tuition that we had in the last example, which was represented by by a T, and then adding 100 onto that. So as you can see, this was 600 plus that 100, and then 650 plus that 100. So what does that do to the mean and the standard deviation? Well, put these in your calculator, calculate the mean and standard deviation, and I've already done that. So the mu of C is 832.5. And that will come as no surprise that it's actually, C was obtained by doing T plus 100. So this is the same as the mu of T and adding 100 on. However, for the standard deviation, it's still 102.8. And that's because just like in Chapter 2, when we add a constant to all the values or all the observations, it doesn't increase the spread. So the sigma of C is sigma of T plus 100, but then that's still just the same thing as sigma of T. It doesn't, you don't add 100 onto the measure of spread. And here's a summary of that. So if we add a constant to every value of a random variable, it does add that constant to the measures of center and location, but not to the measures of spread. And it still does not change the shape of the distribution. So let's put that all together. We actually call these linear transformations because we can kind of represent them by multiplying by a constant and adding a constant, and that looks like a y equals mx plus b, if you recall that as the equation of a line. I would like to summarize that just a little bit back with El Dorado Community College. I want you to see that that final cost, mu sub c, was obtained by saying 100 plus 50 times x. That's the 50 times x was what gave us the t, and then we added 100 on. So when I wanted the mean, it's actually 100 plus 50 times mu of x. But when we look at sigma of c, it's also sigma of 100 plus 50x. But this time, the 100 doesn't affect the sigma. It will just be 50 times the sigma of x. All right, just a moment to talk about your quiz question, which I put it on here. I'm not going to work it out, obviously. But the examples that we have just done were discrete random variables. And this question is about a continuous random variable. But all the same rules apply. So what you'll need to do here is find your new mean and standard deviation. And I just want to point out that the C part this will be a normal distribution question. So you'll do it just like we did in class on Friday, and you'll use your answers for mean and standard deviation like that in the